Um, I'm here today to talk to you about unifying and utilizing Entra ID, or what used to be known as Azure AD, synchronize data from your directories on-prem into the cloud. Now, this is an interesting topic, and was actually presented to me as could you do a webinar about something related to the cloud a few weeks ago? And I've been working on a project with an organization doing just this. Now, it's an interesting because there are multiple ways to do it, and there isn't one solution that fits all. There's numerous different methodologies and architectures that you can adopt to make these kind of synchronization strategies work. So we're going to take a little bit of a dive through these. We're not going to get too much into technical details or bog down in sort of the actual communication elements, but we're going to cover the things that we need to know about from a security perspective. Because to be honest, sometimes the documentation's a little bit light, and unless you've gone through the process of actually trying to make this thing work and do it securely, you don't really know what to expect, what the outcomes are, and what some of the caveats to these processes are. Now, the documentation from Microsoft for Entra ID is definitely getting better, but it really just doesn't cover all of the basics and bits and knowledge that you should know before you start attempting this kind of project. Now, my recommendation is always to try this out in some sort of lab or an enclosed environment before pushing anything out into any sort of production environment, particularly if you're a large organization and you're adopting cloud services, Microsoft 365 productivity services, etc. for the first time. Before we get into that, a little bit about me and why I'm here talking to you this morning or this afternoon or this day. I'm an instructor for SANS. I teach Sec 488, and we've got quite a few runs of this course running all the way up until January and February next year. So if you do decide to do with this course, the Sec 488 Cloud Security Essentials, you can come and join either myself in Paris in November or Ryan Nicholson, the course author, in December at Washington CDI. Awesome event, by the way, if you can make it out there. Kenneth has got a run of a Cloud Defender in January as well, and they got another one coming up in Amsterdam in March. So if you are interested in this course, do have a look on the SANS courseware guide, and you'll find us on there and all of the different runs for that particular event. So apart from being a SANS instructor, what else do I do? Well, I actually work for SANS. So I'm the head of R&D and the principal security architect for the ranges part of SANS. Now, I run a very small, unique boutique team of basically just me. I used to have a colleague who was working with us, but he left last year. And I've been kind of moved over towards the CounterHack team a little bit. So I get to spend most of my working with CounterHack and their amazing team who are currently putting together the Holiday Hack Challenge. Awesome again, by the way. Definitely check that out, coming out in the next 4 weeks. Otherwise, I spend my time researching and developing new types of cyber ranges to facilitate learning. Now, to be a SANS instructor, you also have to be a practitioner. So in order to keep my hands dirty, I also have my consultancy, and I'm the head of security for a social media company, and I have some other NED roles and advisory roles where I help organizations out with things like this kind of project, helping them make strategic decisions on how to maintain visibility and adopt cloud services from their current on-prem systems. This is kind of the major topic of conversation of what we're going to discuss today: identity. Now, identity is quite an interesting element of the cloud, because we're changing the way that we approach defense. When we move to the cloud, we have to take into consideration that the services that the cloud provides are in a public region. They are in a public space. They're not owned by us. We don't affect overall control. We just get a subset of controls that we can apply to try and layer and increase our level of security across that platform. This isn't the same as having your own data center. You can't put up a huge fence around it, install giant burning dogs at the door. You can't adopt the goose strategy, where you put wildlife in between the fence and the building to stop people from coming in. We don't have the ability to shut doors, employ key management systems, and monitor who comes in and out of our services. Because we don't own any part of the cloud, we just rent it effectively. We are at the end of the decision-making process that affects everybody who uses the cloud. Now, the big change for security in this perspective is identity becomes the perimeter. We don't employ next generation awesome firewalls and put against our perimeter, because actually the most extraneous node to all of the cloud services is identity. We have to authorize and authenticate users into our systems inside that cloud environment. It's a big difference. There are many other differences in the cloud, and we talk about that in the 388 class and the 488 class, and then the more aggressive, offensive 588 class, all around cloud security. And identity plays a major part in all of those areas. So let's drive this back a little bit. What is identity? Well, it's authentication, authorization, and accounting. We want to make sure that who's coming to us with credentials is who they say they are. We need to maintain and establish integrity for that particular user. Once they've authenticated, we assign them permissions to do things. We like to keep that as limited as possible as well, the principle of least privilege, as we often refer to it. And that's simply just to reduce the blast radius if something goes wrong, like an account compromise or a token theft. So we want to reduce the permission sets that users have by default to only what they need to be able to do in order to fulfill their role. And then probably one of the most important elements of this is the accounting part. We want to make sure that when we identify a particular behavior or trait or action or an effect against something, that we can trace that event back to a user or a machine or a service. So we can identify what happened, where, and by whom. These are all the key parts of identity. I mean, the cloud, we don't just have to deal with this on our own virtual machines, on our own networks, on our own storage accounts. We have to do this against the API, the programming interface that we interact with that the cloud provider supplies. Now, the API for Azure and AWS is a global service. We can't turn it off. If we get breached, it's not like we can ring AWS and say, excuse me, could you turn your API off for a few minutes while we sort this breach problem out? They're not going to do this. In fact, they'll probably laugh at you and then say no. So we have to protect calls to that API, because effectively when you authenticate to that API and you authenticate with a high privilege account, you can do anything you want inside that cloud space. You can build virtual machines, create networks, destroy things. You can have attackers and adversaries create shadow IT. So they're building infrastructure in the background in places that don't have visibility turned on. You've not got CloudTrail logging turned on, or your Azure activity isn't monitoring those particular areas. Again, this all comes back down to identity. Now, in the, shall we say, olden days, no, let's just go back on what's happening at the moment. We've got things like Active Directory. Now, I've got a long history in Active Directory. I was actually a Microsoft technical specialist since about 2003 with a specialism in Active Directory and group policy management. I spent a lot of my early IT career helping organizations out with problems inside Active Directory. So what is Active Directory? Well, it's essentially an LDAP service. It's a lightweight directory access protocol. It's a database of objects and attributes associated with identifying users, individuals, groups, objects, services, servers, etc. Now, Active Directory is made up, it is formed in a schema. This schema integrates with a lot of other services associated with Microsoft Windows services and networks, such as DHCP, Dynamic Host Configuration Protocol, the issuing of IP addresses across network address spaces. We've got DNS, Domain Name System, the resolution of names against numbers. Humans aren't very good with numbers. We are better with names. DNS solves this for us. It's the address book of the internet, and DNS integrated zones inside an Active Directory facilitate name to number resolution inside our own corporate space. We've got ADFS, Active Directory Federation Services. I'm going to talk a little bit more about this in a little while. The Federation Services allows us to create trust relationships with other domains and other domain forests. And we've got CAs, certificate authorities. The certificate authority that issues certificates across an internal environment. Now, unless you're for a big corporate environment, the chances are you're not issuing your own certificates and you're utilizing third-party vendors to do this. But this is still integrated part of the Active Directory structure and can be used to issue tickets and keys, etc., across that infrastructure. So what's the primary responsibility for Active Directory? Well, it's pretty simple. It's authentication. It takes responsibility of authentication away from endpoint devices. So you build a Windows 10 or a Windows 11 laptop. The first thing it asks you to do is to sign in or connect to the internet in order to sign into your online account. We don't want to do that, so we open up a shell. We run a couple of commands that jumps across the out-of-box experience boot process and allows you to create a local user account. When you have a local user, it just means that the laptop is responsible for handling authentication itself. It's not delegated that responsibility to anybody else. When a workstation joins a domain, joins an Active Directory, what it's doing is it's absolving its responsibility to authenticate to the domain controller. It creates a trust relationship with the domain controller. And so every time a user logs onto that laptop, they're actually authenticating against the domain, and the domain controller is passing back authentication tokens back to the device, which then makes sure that you can then, or that user can log on to multiple services inside that environment. The first iterations of things like single sign-on is eventually powered by Active Directory. Now, Active Directory is quite a complex library and structure. And you can see on the screen at the moment, I've got a screenshot of some properties or the attributes of a domain controller. And that list contains a considerable amount. It's about 1,700 items. And all of these are different flags or attributes associated with that domain controller. These are all stored within the schema, and the schema is what you then control and modify or manage in order to control EUDs, endpoint devices, servers, user accounts, security groups, etc. The Active Directory is a fairly complex beast. We've also got another element to that as well called group policy. I'm not going to go into that in great detail, apart from to say that group policy is a way of applying structured rule sets to devices or users. There's two primary focus points for group policies, the computer policies and the user policies. There's a bit of crossover between them as well. There's some conflicting areas, and there are some changes you can make in group policy that have a perpetual, or what we call a tattoo element, to a workstation. They make a permanent change to that machine. Now let's move on a little bit. Now we've got Azure AD, or just recently renamed Entra ID. And this is a bit of an interesting topic as well, the whole renaming part of that of this service. Microsoft haven't changed anything major inside this space at the moment. They've changed Azure AD to Entra ID. And I think one of the reasons they've done this is they're going to deliver a whole load of new services coming into the future. There's quite a few in preview at the moment. But there are all sorts of new services coming in associated with things like OpenID, federation services, and the unification or the synchronization of things between the cloud and on-prem and between other third-party clouds. So at the moment, we've got a lot of choices about how we handle authentication when we move to the cloud. We can use the cloud native solutions from Azure, from AWS, who have got their IAM. GCP have their own directory structure for authentication based upon the productivity services of Google Workspace. Microsoft, though, are looking to, it appears, take into the space a little bit alongside the third-party identity providers like OneLogin and Okta, because those providing services additional to authentication are services like security detection, impossible login, cloud security posture management, or CSAM. There are huge amounts of services that are bolt-on or additional that are delivered by those third-party platforms. Microsoft appear to be muscling into that. The change in naming structure is potentially around that. If somebody knows from Microsoft knows any different, please reach out to me and let me know. I've been asking around at a couple of the events recently with some people I know elsewhere, but no one's got any definitive answer in relation to that. One of the benefits, though, for this change to Entra ID is actually quite a nice disconnection between the reference of AD. Now, Azure's AD, or now known as Entra ID, isn't an Active Directory. It's not an LDAP service. So it's not a lightweight directory access protocol service. It's not equivalent to what you have on-prem. It has some very similar functionality. It can authenticate users. It can store groups and lists of devices, but it's not as complex in the way that the schema is structured, and it doesn't have as many attributes as you do on-prem. Does this mean it's not as effective? No, it's just that it's not the same kind of service. It's not the same thing as an Active Directory. But you can actually link the two together. You can create a synchronization between the two services and make the data sets very similar. But there are some limitations, there are some restrictions, and there are different ways that we can actually accomplish this. The drive to do this is single sign-on. It's always been the case. We have a problem in the security industry and in computers. We have to rely on passwords. Identity's big issue. And we have to rely on passwords. And as security people, we've kind of created this situation where we rely on users, our first line of defense, and their only tool is a password. It's something that we set some thresholds and some limitations on. They have to then generate the passwords. And the rules vary massively. I logged onto a website the other day. It wouldn't let me use so many different symbols. It was ridiculous. I ended up with a password that was less than 12 characters long, uppercase, lowercase, numbers, and an exclamation mark. And that was practically all I could use. This is not good. That password isn't a secure password. Also, we use phrases like passphrase instead, but we still haven't got used to this, and people still refer to them as passwords. We should be encouraging strong use of passwords. Not only that, we should be encouraging the strong use or utilization of multi-factor authentication. No multi-factor authentication is terrible. SMS-based authentication, where you're essentially handing over authentication token authorization to a cell phone or a mobile phone company, isn't great. They do not care. So you want to avoid using SMS if you can. Push-based notification through things like soft phone or soft authentication services is great, is better, but it's not best. Where push notification with number prompt is better, because again, you have to see both sides of the screen in order to be able to authenticate that user. And then we have right at the top of the chain, the best, things like FIDO, where we have to authenticate the token before we can use the token. These kinds of challenges for multi-factor authentication absolve some of the issues that we have with identity and managing passwords, but not all. Now, the reason we want to synchronize our on-prem services with cloud services when it comes to identity is because we don't want users to have more than one password or one username. We don't want them to have multiple tokens or different soft applications on their mobile phones or YubiKeys in order to be able to authenticate and access different services. I know this. I've worked in some organizations where you end up with at least 100 different usernames and passwords, depending on the platform you're connecting to. And it's not the fact that it's a little bit awkward for users. It's not the fact that it's difficult to manage from an administrative point of view. It's the fact that the users are being encouraged to be lazy when it comes to creating those passwords. Passwords will become the same. Users aren't going to remember 100 passwords. So we want to synchronize these services, unify them together to create single sign-on capabilities. There are some tools that allow us to do this. There is a synchronization system between Entra and an on-prem Active Directory. This is what this entire webinar is going to focus on. So now I'm going to take a little bit of a dive into the options that we have and what's available to us in order to be able to successfully get our on-prem directory structures to synchronize with the cloud-based structures and utilize them in a way that suits our organization and facilitates the features and functionality that we need for our users. Not only that, but also gives us good visibility so we can see exactly what's happening inside our environment and detect indicators of compromise against our accounts, against our structures, against our environments. So let's take a little bit of a run into these ones. And I'm going to get into a little bit of detail on the next couple of slides about the different options available. Before we get to the end, we're going to talk about how we actually decide which one's going to be right for us. I have got a little lab set up at home. I've got a domain controller and a management server set up, and I've got a synchronized to one of my Azure AD or Entra ID accounts. And I'm going to give a little bit of a demonstration of the actual software as well, just at the end of the talk. So not doing bad. So I'm around 20 minutes in, so I think we've got plenty of time. The first one. So we have a few options available to us to synchronize our on-prem services with our cloud-based Entra ID accounts. Password hash synchronization. This is probably the easiest one to implement, and it has some really useful functionality, but it doesn't include things like single sign-on. This just creates a synchronization between our directory structures, both at our on-prem services and our Entra ID. We end up with password consistency. So the password that's set in the cloud is also the password that we have on-prem. And there are also facilities to do things like password write-back. Now, password write-back is effectively allows our users to change their password while connected to a cloud service, and that password change will apply to our corporate on-prem enterprise Active Directory, our infrastructure on-prem. Now, the way this works and the way this is implemented is often utilized by smaller businesses or organizations who are really just sort of initially adopting the cloud and want some synchronization between their accounts so that the users don't have to have multiple usernames and passwords and things. So the scenario would be, for example, you have an organization where most of the users exist on-prem. You may have a couple of remote workers wandering around. Everyone's on desktops and laptops, maybe tablets, mobile phones, etc. They're utilizing Microsoft 365 productivity services. They want to be able to access those without having to repeatedly log in or have multiple sets of usernames and passwords to access that service. We use password hash synchronization to synchronize the user accounts between our on-prem and our online services. Now, there's some differences here in relation to the domain. Domains on-prem, quite interesting. We either run in what we call a split-brain DNS system or a singular DNS. Split-brain DNS is where we have the actual public domain name as our local domain inside our network environment. Now, traditionally, this was always kind of opposed by Microsoft and by the documentation. They said, if you do this, it makes things a little bit more difficult in regards to DNS resolution for outside services. So split-brain DNS was always kind of the one that you weren't really supposed to do, but we used to see it a lot, quite frequently. The other is where you have a localized domain. So, for example, you have a domain like, for example, nox.local. So nox.local, when we map that to Office 365, well, the nox.local domain, we cannot attach to our tenant and provide evidence that we own it, because it's not an externally referenceable domain. It's not a true TLD. But what we can do is we can map the directory structures, so we can map the local domain usernames and the online cloud-based usernames, utilizing the synchronization software in order to be able to create a unified view. Now, this is where we pass over what we call UPN, a user profile, which utilizes the public domain name to authenticate onto localized services. So, for example, mine would be, and in the sense of this one, would be my username will be Simon at nox.local for my local domain, and for the cloud domain, it will be Simon at pipernet.co.uk, which is my domain that's currently running inside that tenancy. But I have to be able to map those two domains together so that I can log on with the same username and password across the board. That's what password hash synchronization has the capability to do. So how does this actually work? Well, Going back to Active Directory, we have domain controllers that synchronize communication or synchronize all of their attributes inside an Active Directory schema. They use a system called DRSR to do this. It's a directory resolution service that communicates over a remote procedure call to synchronize the directory structures together. Now, that synchronization happens over a 15-minute period. Apart from the password element. The password element happens a lot faster. So a change of a password of one domain controller is almost effective immediately on every other domain controller inside that environment, regardless of how many domain controllers you have. The password synchronization is quicker because the password synchronization can be the difference between authenticating a user and potentially resetting or changing a password that's potentially been forgotten or lost or shared accidentally. So password synchronization is quick. Password synchronization between Azure AD and Entra ID via the password synchronization software is also pretty quick. It's a 2-minute synchronization schedule. So we've got to get data from the on-prem Active Directory domain controllers into Entra ID for cloud. How do we do this, or how does the application do it? Well, this is where we utilize the synchronization software provided by Microsoft. Now I'm just going to jump through and just change the view that you see at the moment. You should now see my virtual machine running, and I've got the Microsoft Entra Admin Center logged in. This is one of the control centers for Entra ID. And if I go to the home onto Entra ID and go to the actual Entra ID portal, I can see here that I've got my domain name listed with the primary domain associated with it. You can see how many user accounts, everything else. There's a link in here to download the software that allows us to synchronize my on-prem systems with the cloud-based systems. So if I just minimize that window there, you can see here I've got an application called Azure AD Connect. That is downloaded onto a workstation, not a domain controller. It's downloaded onto a workstation, and what it does is it authenticates your domain controller and then shares information with Entra ID. We're going to look at that in a little more detail in a few slides' time. So how do we actually get the data then between the on-prem and the Entra ID? Well, there's a little sequence of events that happen in order to facilitate that process, but also we maintain security because we don't want those passwords being leaked and they're being broadcast over a public internet communication channel. So we have to be secure. So how does it do it? The the domain controller already has a process to share passwords in between other domain controller services over an RPC connection. Now that RPC, the remote procedure call, can be delivered over TLS or SMTP if we want to send it over a mail channel, for example. But it's encoded, or the synchronization data is encoded or encrypted in the same way. So what happens is the DC encodes the MD4 element of the password hash. So what it does is it takes the password, hashes it into MD4, and then creates an MD5 hash, adds a session key and a salt, and that data is then shared to the agent, to the Active Directory synchronization agent. Why does it do it this way? Well, the agent doesn't actually get to see the password. It only gets to see the hash of the password before it adds some additional data to it. The sync agent then uses that data, reverses the process to retrieve the original MD4 hash from the envelope, thus therefore never actually having sight of the password. It only ever sees the hash of it. The sync agent then passes this through several changes in order to create a package that's going to deliver over the public internet, because this is the risky part. We're now taking this super sensitive data, this secret or a hash of the secret, we are transmitting it over a public channel. We've got to do something with it before that happens. So it goes through a little bit of an extra additional process. To protect the data further, we take this 16-byte MD4 hash, we turn it into 32-byte hex, and then we return it back to a binary in a UTF-16 encoding, which gives us then a 64-byte string. We add a 10-byte salt to that value, and then that entire string of data is combined with the original MD4 hash plus a user salt, and it's passed through PBKDF, which is a derivation formulation. This derivation formulation plus 1,000 iterations of HMAC 256 result in a 32-byte hash that is transmitted to Entra ID over a TLS communication, so over 443. Now, that seems like a considerable amount of processing in order to get that data across, but it's all about protecting that secret or the hash of the secret. So when a user then actually signs in with their UPN to Azure, what they're doing is they're validating, or they submit their password to the Entra ID. Entra ID goes through the same process of taking the hash, looking at it as from an MD4 hash perspective, runs it through the MD4 plus the salt established during the connection, plus the derivation functions, plus HMAC 256 iterations, and then if the hashes match, the user is authenticated. So we've taken not just the user information itself, the password, the secret. We've taken that and hidden it because we've not used the actual secret. We've used an MD4 hash of it. We've added a user salt, a system salt, and an actual enterprise communication salt that's established when Entra ID is installed. And all of that information is therefore used to authenticate that user. This is how we can allow things like password reverse writing to happen, or group writing as well. We can synchronize the two services in a bi-directional sense. We have effectively a two-way trust relationship between the two. Password hash authentication, though, isn't the be-all and solution for everybody. It doesn't fit everybody's model because it doesn't have single sign-on services. We'll talk about those in a few slides' time. But before we do that, I'm going to talk about pass-through authentication. Now, if you are a fairly heavy user of Microsoft 365 and the productivity services and suites, etc., you may actually want your authentication still to be handled entirely by your on-prem services. This is where pass-through authentication happens. So if you are yet to establish a pure or full trust with Entra ID or with Azure services, then maybe what you want to do is utilize pass-through authentication so that all of the authentication actually happens at your on-prem services. So again, we utilize the agent services from the sync application. We install it on a workstation or a server close by to the domain controllers to have access to the Active Directory domains. It's got to be on a domain joined server. And what happens is any authentication attempt against Entra ID is actually sent back to the domain controller and is processed by the domain controller as if that user was logging on to the corporate domain. Now, what are the benefits of this? Well, the major benefit is we can still apply our very strict and controlled group policy elements that exist inside our Active Directory, and with our full range of attributes, group memberships, etc., all associated with our Active Directory. We can still utilize all that even though we're authenticating through the cloud platform to our domain controller. One of the limitations is we have to maintain and establish communication between the cloud platforms and the domain controller. So if there's interruption to communications, it can cause us some problems. Now, pass-through authentication is a little bit, there's a few less moving parts, because really what's happening is when a user tries to authenticate to an application, if no session exists or no bearer token is passed to that application, for example, a user logging onto a laptop, signing into Office 365's Outlook, if there's no token associated, then the application will push back and refer that authentication back to Entra ID. Entra ID grabs a username and password combination that's again encrypted with a public key infrastructure and puts it into a queue. So it essentially silos it in a queue. Now, on a periodical basis, and it's less than 30 seconds or so, the online or the Active Directories synchronization service that's running on the management server will go off and grab what's in the queue from Entra ID. They will pass through and use its own private key to unwrap the package of the username and the password that's been delivered. And then the Active Directory evaluates that data. And if it responds with a positive response, the request is then forwarded back to Entra ID with the information related to authorization. If there is a requirement for multi-factor authentication, which is being dealt with by the cloud, then a token is sent back that then demands multi-factor authentication token is therefore used. before the user then gets access to that token. So multi-factor authentication still being handled by the cloud platform, but the core authentication is being handled by the Active Directory domain controller, which is also an interesting one because that's where the logs are stored. So when it comes to our traditional or current capability with our on-prem services of logging and identifying when a user's logged onto a system, then we have it there. Now, pass-through authentication, again, is still not single sign-on. We are logged onto we log onto a device, onto a laptop, and now we open up Outlook, we'll be prompted for a username and password. It's not a seamless single sign-on service. If we want that, we have to take it one step further. Now we start talking about federation. Now, federation is a facility that's utilized by or provided by Active Directory federation services or some external services. For example, Okta, One Login, for example. Federation is all about creating a trust relationship between you and a third-party service. So what you do is you create a trust relationship that has the authority to delegate authentication to a third-party service. So you can do this in lots of different ways. For example, using an IDP and an SP, so an identity provider and a service provider. The service provider is the one that's being requested for the services, and it redirects the user to identity provider to get authentication tokens that come back. They're often shared through SAML, simple assertion language. What happens is we get essentially some information back from the identity provider, tells us what level of authorization or how we should be handling that particular token. So this is federation. This is how we federate services together. What this is leading to, though, is single sign-on. Single sign-on is essentially where a user logs onto a device, they open Outlook, and they're immediately authenticated into that application. They might also be immediately authenticated into a SharePoint site or a OneNote document or into a OneDrive storage account, anything related to those particular productivity services. Single sign-on facilitates this and creates a seamless communication between those two environments. Benefits of this is users only have to remember one username and password. They don't have to repeatedly log into services either. We can combine single sign-on services with things like password hash synchronization or pass-through authentication in order to give us a fallback position as well. We can create the single sign-on services to be opportunistic. Essentially, single sign-on works unless something fails along the line, and then it will fall back to using either password hash synchronization or a pass-through authentication in order to get those users to log on. One of the benefits of with things like single sign-on services as well is that we can utilize a single username and password, but the username is then formatted in a standard way. It means that we can sign on to our workstation using our full UPN, or we can sign on using our localized version, for example, the domain name / your username. It doesn't matter which, and it can be determined by the platform owners, the administrators, on how they want the usernames presented, but there's a consistent approach to it across the board. With this as well, we can deploy all of this through group policy, and it supports everything back until Windows 8 as well. So we've got a lot of backwards compatibility capability in here. Now, I hope there's not many organizations that are still utilizing Windows 8, but it wouldn't surprise me if they were. It was only 7 years ago I went to Incident Handler, an organization who was still using Windows XP machines. So let's, hope that we're sort of moving forward with that. But I mean, definitely there's a lot of users still in a corporate environment on Windows 10. There's definitely users on Windows 8, maybe even going back to 7. Well, fortunately, there are 2 ways that we can implement single sign-on services in both a seamless and a web application approach. So we'll just have a quick look at those 2 before we move on. User attempts to access an application. If the session doesn't already yet exist, then the user is redirected back to an authentication service, for example, Entra ID. So this happens with a redirect like a 403, for example. The Entra ID challenges the browser by a 401 unauthorized. So you get a response back from the browser, from the application that says you're not authorized, you've not presented your request with a token in your browser. So the browser then goes back and requests a ticket from the Active Directory. This is a domain joined Windows machine. It has connections to the Active Directory. All of its authentication has been delegated to the AD in order to perform these actions. So the application, the workstation knows that its authentication is handled by an Active Directory. So it goes off to the Active Directory, goes through the Kerberos authentication progress, and a ticket is then reassigned back. It's handed into the browser header, into the request header, and again, along with the computer secret. So this is the trust relationship between the workstation and the server, and then the application is presented with that token, and the user should then be allowed into that application. We've also got a native process as well. Now, this is a little bit more complicated, as you can see from the graphic here. There's a number of different steps that happen in order for this to work. Again, this requires a domain joined computer. So if a user logs on to a workstation and they don't already have a session that exists from an application, the application will attempt to gain access to the token from the workstation itself. So the workstation, when a user logs on, goes through an authentication process of authenticating and delegating a trust relationship between the workstation and the Active Directory controller, as well as the user and the Active Directory. Once the user is authenticated, they're issued with a Kerberos ticket, a token, and various other information about their authorization and level of access to services. The applications that communicate and interact with those have that availability as well. Now, this app could potentially send the data via a WS Trust MEX endpoint. You might be asking, what on earth is one of these things? This is a trust mechanism that deals with metadata on an endpoint service. So it's a service that relays information back and forth between elements inside the application authentication sequence. It provides that chain of communications that hands over and presents the Kerberos tickets. So if we have the app retrieve this Kerberos ticket, it's forwarded to Entra ID where this application is running. So for example, Outlook, and that is validated based upon the SAML token that's generated. Again, utilizing federation to do this. There's an established trust relationship between the two endpoints that delivers this seamless communication. Which one do you choose? Which one becomes the most appropriate for your organization? Well, actually, Microsoft provide this little flow chart to help you decide what kind of services you want. So I'll have to go through this one and from a point of view of the organization I've just been working with. So we start. The first question is, do we want Azure AD to handle the signing completely in the cloud? Well, for the organization I've been dealing with, they didn't. They have a very structured on-prem system with a redundancy across multiple sites, and they've got great visibility of all of their domain controllers, providing centralized logging, etc. And they've got a SIM that's included in that process. So rather than having to re-engineer their security solution, what they wanted was a system where they could utilize the cloud platform services, but they wanted authentication to be handled in-house. So no. Do we want to integrate with an existing federation provider? Again, they were open-ended to this one. They hadn't quite yet decided about what was going to be the best solution for them. They didn't want to start including multiple third parties either. So they decided they wanted to go with their own in-house, again, version, so not integrating with a third party. Did they want then sign-in disaster recovery or leak credential reports? And again, they provide all of this from their internal perspective regardless. So the answer was for this one, for their freely question was no. Do they want a sign-in requirement not natively supported by Azure AD? Again, they got nothing additional outside of the standard productivity suite, so this wasn't relevant for them. And then did they want the sign-in disaster recovery or leaked credential reports? No. So their default solution was a pass-through authentication. Now, if they do want to go through the perspective of utilizing some of the additional features and authentication services at some point in the future, they can still use password authentication, but they can also implement things like password hash synchronization or move on to a full SSO solution. These use cases for this vary massively. There's numerous different ways you can approach this, but deciding, like experimenting, finding out which is going to be the most appropriate for your organization is critical You really only get an opportunity to do this once. And the opportunity to migrate and upgrade systems as you move into the cloud is an amazing one. So as we wrap up this session, we're about 45 minutes in. We need to talk about the big issue we have when it comes to monitoring and visibility. With password hash synchronization, the authentication happens in the cloud. We don't see authentication and objects appear in the Active Directory on-prem. We don't see the domain controller generating logs for events that have happened. With pass-through authentication, we do. We see that all on the localized domain controller. And with federation and SSO, depending on one of the modes that you use and whether or not you append it through pass-through or password hash, depends on where your logs then arrive. So, old school, again, back to our domain controls. I keep saying it's old school. It's still very current technology, but it's kind of a very similar to the way it's been happening over the past sort of 15 years or so. We have log sources and searches and things that we can compare or contrast or detect that happen on a domain controller. Things like event ID 4624, an account was logged on, or 4625, an account failed to log on. The dangerous one being the 4624. Yeah, that's the one where somebody's actually successfully authenticated to our services. Again, other event IDs that are important as well, 4770, a ticket was renewed. A 4648, where a login attempt was utilized using explicit credentials, as in, for example, a run as or a form of alternative credentials. We see that as part of that pass-through authentication. So they're the ones that we really want to look at from an on-prem perspective. Now, if we're happy for Entra ID to actually provide our authentication services for us, well, then we are also moving visibility of our authentication system into the cloud. And we have to use things like the Entra Admin Center to identify traits and patterns of behaviors, things like successful logins, failed sign-ins, and sign-ins with risk events associated with them. Now, with Entra ID, if you want to centralize that logging data rather than just utilizing it through that portal, which is in a big environment, extraordinarily painful to use, then we want to utilize the capability to centralize that log data and move it potentially into log analytics. This is where we have to be very careful, and this is where experimentation comes into play. You can't turn on some of those features unless you subscribe to Premium 1 or Premium 2 in Azure's Entra ID. So if you're utilizing the basic version, you don't get the facilities to do this. If you've got more than 50 users inside your environment, you're going to have to subscribe to additional services in order to be able to get access to that data and utilize it in an efficient way. Otherwise, your analysts, your defensive engineering, your defensive teams are going to struggle to maintain good visibility of what's happening inside that environment. There is another way. There's also the programmatic access. It'll be accessed through Microsoft's Graph API. It's just gone through a lot of re-engineering, some major changes, but the approach is still the same. You basically look at your audit logs and sign-ins, plus the audit logs and directory audits in order to gain access to the same information. So sign-in events come through the sign-in stuff, and audit logs, which is changes to your Azure infrastructure or your Azure tenant and activity within that tenant, negating the reads because they aren't logged by default, but they are stored in the audit logs, directory audits. I hope this has been useful for you this morning. And it's been sort of a crash into authentication ID. There's a lot more of this is covered inside the courses that SANS provides. And we've got some other events that are coming up as well. We've got Sean McCulloch, awesome guy and author of some SANS courses, who's writing a Building Better Detections for AWS. So that's happening on Thursday, the 16th of November. And we've got a least privilege and a veteran third-party cloud account access written by Ryan Nicholson, the course author for Sec 488. That's happening on Wednesday, January the 17th. So lots of activity on the SANS cloud security. Do come back and check this out. And I am open to any questions. So I will hand over to Lisa, or Laura, sorry, who will go through and give us a bit of an insight into the Q&A. Thank you for listening so far.
Wonderful. Thank you for sharing your wealth of knowledge with us, Simon. We've got a couple questions here. The first one, vendors use different claims / attributes. how to integrate third-party SaaS into corporate SSO.
Oh, yeah, this is a really hard one. And if you're going through this process, I do feel for you. You don't always necessarily have over control or overall control or oversight over the availability of data that comes from a third-party provider. So this is where you have to know the third-party provider is what they're actually offering. And if you don't have access to the data and you're already embedded in those systems, you've just got to make do. So yeah, it's a difficult one. They're all very different. Go for, examine the options and what they offer you before you subscribe to them is my key advice.
Terrific. The next question. We often work with clients who state they do not enforce MFA for admin/privileged accounts when on-prem. Would pass-through authentication be a potential solution to this?
Not really. If you've got an organization who are actively objecting to utilizing multi-factor authentication, pass-through authentication isn't going to make your life any easier, unfortunately. What it does do is it maintains the authentication visibility on your local domain controllers, which is where your security systems are probably plumbed in. But multi-factor authentication in pass-through mode actually happens at the cloud side, not at your domain controller side. So if they are still objecting to utilizing multi-factor authentication, well, they're still going to object to it regardless of whether or not it's dealt with by Entra ID or even any other third-party provider. One of the benefits, though, and I will mention this, in Azure AD and Entra ID, you can actually run your own multi-factor authentication service. So rather than utilizing the standard offering from Microsoft or from Okta or any other third-party provider, in P1 and P2, you can actually provision your own multi-factor authentication service as a service and then utilize that and apply your effective controls from that position. It gives you more overall control, and it may just tweak the objections that you're getting from your sort of administrative side in order to facilitate, additional security by utilizing an additional token. So have a look into that. There are some options available to you.
Terrific. That's all we have, Simon. Oh, wait, I spoke too soon. One more came in. My biggest issue with Entra ID is managed device in different flavors, such as Linux, and some sites like SSPR does not support direct integration with other MFA solutions like conditional access. Will there be any improvements?
Yes, so there are improvements coming through, and this is one of the reasons why Microsoft renamed Microsoft AD to Entra ID. This was to get away from the myopic thought process of, well, hang on a minute, we only authenticate Windows devices, etc. So there are plans to introduce authentication services, and they already exist. It's just they're not very well publicized. So, for example, Ubuntu 22.04 LTS version supports OpenSSH version 2, which includes a PAM module, which also includes the ability to do MFA over port 22, but it also synchronizes and shares data really well with Entra ID. And its logging mechanism is through an AMA agent to Azure's log analytics and monitor services instead of the traditional agent as well. So there is movement in this space. There are additional features coming in. Watch out for what comes through preview on Entra ID. Regarding third-party ones not working and not playing well, they're going to start improving their posture as well. Because to be honest, the uses of Microsoft Entra ID and Azure services are growing. They are picking up more and more market share, and I've spoken to lots of different organizations who are moving away from AWS into Azure. And this is just recently, within the last 6 months. So watch the space. More support is likely to come very soon.
And with that, there are no more questions. So Simon, thank you so much for sharing your knowledge. Attendees, thank you for being with us. You can find your CPE certification for all completed SANS webcasts by logging into your SANS portal account, navigating to your account dashboard, and then click My Webcasts. You can download your CPE certificate on the right-hand side of the page. And with that, we hope you all have a wonderful rest of your day and hope to see you again soon at another SANS event. Thank you.
Thank you. Bye-bye.